All right, so I did email the notes, so they should be in your inbox. This is actually from last time. This is just an example I really want to do with you guys real quickly. So if you remember last time, we had this, let me go back to it. Where is it? We had this basically another way to write down a quadratic function, if you remember. Okay? Basically here, what happened was we wrote it this way, which is standard form. The a, that's the leading coefficient of the polynomial, as in the other form, of the quadratic, excuse me. HK is the vertex of the polynomial. So HK is actually the vertex. Okay? And remember, basically where the graph changes direction, the lowest or the highest point, depending on if K is positive or negative. And what I did go through last time with some of these examples was if you know the vertex and you know the quadratic function passes through a certain point, then you could figure out, you can get a formula for the quadratic function. You can actually get it easily using this. I mean, generally what's going to happen is the vertex will be given, so that will give you what h and k are. Then you'll have to figure out what a is, but that's what the other point is for. So the other information is to figure out what your a is. So, all right, so let me go back to this. I mean, these I was going to have you guys work on, to try them out for yourself. Maybe the second one I'll do, but let's do the first. Well, let's do them together. So, okay, so again, we want to find a quadratic function, right, whose vertex is this, -1, 3, and it passes through the point 3, 5. So we know the vertex, we know where the point passes through, okay? All right, now we have f of x equal to this, right? So again, we're going to use our standard form. I don't remember what the other form is called that we use, but this is called the standard form. So from here, right, we know what the vertex is. In other words, this point is equal, let me see if I can write it out with this. This point is actually equal to h, comma, k. Remember, that's our vertex. What I'm trying to say here is h is -1 and k is 3. So we know what h and k are. Okay, what do we do? Well, let's plug them in. So we have x minus -1, okay? Remember, it's always minus h. So h in this case is negative. So we're going to have x minus negative. And so k is just 3, so we substitute. So we have a times x minus -1 squared plus 3, which is this. So again, I just substituted h here for -1, and I substituted k for 3, as you can see. Now, what we also know is f of 3 has to be 5. How do I know that? Because this point is on the graph. Remember, if a point is on the graph, that means the function maps the x-coordinate to the y-coordinate. So f of the x-coordinate is the y-coordinate. In other words, since this is on the graph, we have to have this. We have to have this. Okay, so we know what f of x looks like. Let's plug it in. So we know that 5 has to equal a times 3 plus 1 squared plus 3. So again, I replace x by 3. Our output has to be 5. So this equation has to be true. And of course, 3 plus 1 is 4. We know 4 squared is 16. So we basically get this equation where a is the unknown. I put the a like after 16 because it's the unknown. I mean, if you left it in front, I don't think it would be wrong, but really as a convention, it's better to write the unknown after. But we have to figure out what a is. That's not so bad. That's just basic algebra, as you can see. So from here, right? Just check, make sure I'm recording. Okay. So from here, what we're going to get is this equation. Okay, and again, the unknown should be on the left side of the equations of the equality symbol. So what I'm going to do is put this on the left side, this, as you can see. So we have 16a plus 3 is 5. Now we have to solve this for a. No big deal. We got to isolate it, right? You know, it's just like when we solve for x. We want to isolate. Same idea. So we're going to subtract 3 from each side, right? Because we want to get a all alone. We have 16a is 2. We don't want 16a. We want a. So we divide by 16. Whatever you do to one side, you do to the other. I don't know why I didn't put this over here, but you get a is 2 over 16, which you can reduce as 1 over 8. You could do that if you want. Reduce it as 1 over 8. Actually, let me just write that. Not sure why I did it to one side, not the other. But I mean, the answer's still right, though. So anyway, just a little typo error. But either way, we get this. F of x is 1 over 8 times x plus 1 squared plus 3. So this is our quadratic function. I mean, you could graph it if you wanted to as a check. I mean, I didn't do that, but we could do that. Right. That's good. And notice also, if you think about it, let me do this. I wasn't going to do this, but bear with me. I think it's important. We know, we know that the vertex is -1, 3, right? So negative x up 3. So we're going to be somewhere here, right? The vertex. And since our a is positive, that tells us right away the graph's going to do something like this. In other words, it will have a y-intercept. I mean, it's going to cross the y-axis. Where? I don't know. Although we could figure it out. I don't think it's too hard to do that. But notice it's not going to have any x-intercepts because it's above the x-axis and it's pointing upward. It's just something I wanted to point out. So even though we're not actually graphing it with Desmos or something, because we know the general shape, we know the vertex, we can see that, oh, well, this is not going to have any x-intercept. So that's all. Just something I figured that would be good to point out. Okay. I hope it makes sense. So let's do another one. So for this one, you know, same idea. We have the quadratic, so we have the vertex, right? We're told it's 4, -2, and we're told that it goes through 1, 7. That's what we're told. At the quadratic function, right, the vertex is 4 - 2, and it passes through the point 1, 7. So because of that, we can figure out what the quadratic function is. So this is our vertex. And again, okay, let me write it out. And again, the vertex is always of the form h, comma, k. Let's see if I can figure this out. So this is what the vertex looks like. So h is always the x coordinate, which in this case is 4. K is always the y coordinate, which in this case is -2. And so from here, we're going to get h is 4, k is -2. So what do? We plug them in. H we replace by 4, k we replace by -2, so we have -2 here. Okay, well, what do? We don't know what a is. What we do know is that 1, 7 is on the graph. Again, as I have here, the function maps 1 to 7. The x coordinate is mapped to the y coordinate. In other words, f of 1 has to be 7, as I said before. So from here, we're going to get 7 has to be a times 1 minus 4 squared minus 2. And so from here, we're going to get a times minus 3 squared minus 2, as you can see. Let me just see something. Oh, that's fine. Okay. Here. So that's what we have here. And so from here, what we get is 9 times a minus 2. Minus 3 squared is 9. So in other words, we need to figure out we need to solve this equation for a. A is the solution to this equation. Okay, that's good, although it might be easy to see what it is right away. But let me go through the process anyway. I try to err on the side of caution, so to say, because I don't know everyone's math background. Everyone comes into the class with a different background, but that's cool. Makes it fun. So anyway, we have this. So again, we want to solve for a. So what do? Well, let's add 2 to each side first. We get 9a is 9. And so as you can see, 9a is 9. And why did I not divide over there? So basically, as you can see, we divide both sides by 9. And we get a has to be 1. And I did not write it because, if a coefficient is 1, we don't write the coefficient if it's 1. Okay, that's cool. So we have that example. So again, that's really the end of 3.1, section 3.1. All right. Yeah, pause the recordings.